Okay, so assignment number 1. So the idea is we have a producer and a consumer. These are two separate processes, and they are running concurrently, and they are communicating through a shared memory buffer. So there is a buffer. There is a shared memory buffer that this producer and consumer are using to communicate. The buffer has a header. So it has a header that has the buffer size, the item count, in and out. Then there is the actual body of the buffer that has the items in it. So this is, item 0, item 1, item 2, and so forth. Now, in order for the problem to be interesting, what should the relation between the buffer size and the item count be for an interesting problem?
Very close together.
Close?
Yeah, so if you want to make it interesting, then you might want to make it so that consumer has to consume for the producer can produce another one.
Okay, so in this case, what should the relation between the buffer size and the item count be?
Item count plus header is buffer size.
In that case, it will not be a bounded buffer problem, right? If the item count is less than the buffer size, it will not be a bounded buffer problem. Like if the item count is 8 and the buffer size is 10, the problem is trivial.
So it has to be greater than the buffer size?
Yeah, the item count must be much greater than the buffer size. So for an interesting problem, the item count should be much greater than the item count should be much greater than the buffer size. So with a buffer of size 10, maybe I have 1,000 items. So how will that happen? How can the producer produce 1,000 items and the consumer consume them with a buffer of size 10?
Reuse.
Yeah, reuse, exactly. So the producer can produce and the consumer will consume. And whenever an item is consumed, the producer can just reuse that cell in the buffer. In the scheme that we described last time, remember the examples that we went through last time? So that scheme will fill, in fact, n minus 1. So if the buffer size is 10, we will only use 9 of them. So when the buffer has 9 items, it's considered full. Okay. So now, if we look at the code, so there will be, like I said, two processes, two executables, a producer and a consumer. So this is the main. The main will read 3 command line arguments. One is the buffer size, one is the item count, and one is the random seed. Random seed because it will be generating random numbers, and we would like to have the flexibility of generating different numbers each time if we want. So if you change the seed, you will be generating different random numbers. Okay. So now, how will the producer is the parent, so it's going to fork a consumer, and it's going to launch the consumer process here. So the consumer process is launched as a child process. So the consumer will be a child for the producer in this case. So launching means just loading and executing this executable, which means that you will have to compile the producer and the consumer separately. So you have two executables to compile, producer, consumer, and then this executable is going to load this executable. The producer executable is going to load the consumer executable as a child. Then the process, the producer will produce. So there is a function that produces. So what does this function do? So you'll have to write the code for this, but what do you think it will be doing? What does produce here mean?
Are we just producing random numbers or something?
Yeah. So to have a loop with bound item count. So if item count is 1,000, there will be a loop that executes 1,000 times and generates 1,000 random numbers. That's what the producer would do. Now the consumer, so the producer is going to wait for the consumer after it's done producing. So this is where during this time, they are running in parallel. In fact, once we launch the consumer, both processes are going to be in the system, and they're going to be running in parallel, and they will be competing for CPU cycles and other resources. And by the way, whenever two processes are running in parallel, we can never make any assumption about speed. We can never assume that producer is going faster than the consumer or consumer is going faster than the producer. The speed will depend on other processes in the system. In fact, with this program, if you rerun your program, you may get different results, because when you rerun it, the relative speed will be different, and you will see, you will get to experiment with this. Now, one important function that the producer calls is the init shared memory. So this is a function for creating and initializing the shared memory object. And in that function, you just put the three APIs that we showed in class last time. So there are three APIs: shared memory open, that creates the shared memory object, ftruncate to set the size of the shared memory object, and what's the third one? Yeah, the map, exactly. The map, which will map the shared memory object to a pointer in the producer address space, and that producer is, pointer is this, shared memory pointer, G for global. So it's a global variable. So you will assign the map to this. So you're just going to say G shared memory pointer equals mmap. Assign the return value of map to this. And then shared memory is pointing to this. Then you will have G shared memory pointer pointing here. Yes?
I had a question for when the buffer size is, because we can set it between 0 and 1,000, right?
Between the buffer size, yeah, there is a limit, yeah.
So I was wondering about the cases when 0 and 1, when we set that, how that's interacting.
Oh, yeah, don't worry. So don't worry about this. So when the buffer size is 0 or even 1, you cannot. So you can assume that it's greater than 1.
Okay, gotcha.
Yeah. So we're not. You can check. We're not gonna test your program using a buffer size of 0 or 1. Well, that's a corner case that a good program should check for and reject. So if the buffer size is less than 2, then you should reject that. But we're not gonna test your program on this. Okay. All right, so once you do the mapping, then shared memory buffer is pointing at this. Now, on the consumer side, the consumer will again do the shared memory, will call the same three APIs, shared memory open, no, two APIs. It doesn't have to truncate because it doesn't set the size of the buffer. So it will make two API calls, shared memory open and mmap to map, and it's going to map it to a pointer that's also called shared memory buffer pointer. It has the same name. By the way, it doesn't have to have the same name. If it has a different name, will that work?
No.
Why? So I need an explanation, not just a guess.
Because it's just storing the address.
Yeah, so it's storing the address. You can call this name anything you want. You can give it your own name if you want. It doesn't matter what the name is. You know, it's this is just a variable name in the address space of the consumer process. So first of all, remember that operating systems don't know about variable names. An operating system does not know about variable names. An operating system doesn't understand the whole concept of a variable name. The operating system looks at the process as a sequence of instructions, as machine instructions. And it just loads that process and gives it the CPU so that it executes these instructions on the CPU. So it has absolutely no idea about variable names. But then how can we make the producer and the consumer map the same object? How do we tell the operating system to map the producer and the consumer to the same object?
They both have to know the same address.
How? So we are making these APIs. What's the parameter that we pass to the APIs that will tell the operating system to connect to the same, to map the same object? So there is something that we mentioned last time. Okay, so the object has a name. So that's an object name. That's something that the operating system understands. When those APIs, when you do shared memory open, with shared memory, there's one of the parameters is a name. And you must give it the same name. And what's that name? Homework 1, your name. Okay? Homework 1, your name. So if you just call it homework 1 and 2 students are running on the same machine, then you may be mapping to another student's shared memory object. So this is something that you pass to the operating system, and this is a name that the operating system understands. Operating systems do not know about variable names. Now, so what will the consumer do? The consumer is going to read the header so that it knows the buffer size and it knows the, even, I don't think it needs to know, no, it needs to know the buffer size. Yeah, so it needs to know the buffer size, it needs to know the item count, it needs to know in and out. So it needs to know these values. It's going to read the header, and based on this, it's going to be consuming. So if the item count is 1,000, the consumer is going to have a loop that goes from 1 to 1,000 that will consume one item at a time. Now, how will it consume? So we have to have ways of reading and writing from the shared memory buffer. And these are provided to you. So I'm providing you with functions that will set these header values. So there is a set and a get function provided to you for each field in the header. And there is a function provided for you to write an item at a given index in the body of the buffer. So so you just call these, but you need to understand how they work. So I'm giving you the implementation. So there is set buffer size, set item count, set in, set out, and all of them call a set header value. And set header value looks like this. So what set header value does is that it will calculate the address for that header value. So for the buffer size, the address is this. It's at offset 0. And the item count is at offset, the size of an integer plus 0. So if it's a 32-bit integer, then this is going to be at offset 4. So this calculates, this is the offset plus the base, and this calculates the address of that item in the header. And then we just copy. We copy the value into that pointer, and then it's in the shared memory buffer. Now the key idea in this assignment is to always remember to write things to the shared memory buffer, because if the producer modifies a certain variable in its own address space and doesn't write it to the shared memory buffer, the consumer will not know about this. And I will give you an example in a minute. So always keep in mind that anything that you don't write to the shared memory buffer, the other process will not know about it. These are two processes communicating through shared memory. So for example, okay, let's draw this in memory. So this is a memory image, and in memory you'll have the producer. This is the producer, and let's say that this is the shared memory, and this is the consumer. So the producer will have its own values. It will have, in, out, item count, and buffer size, among other things. But in shared memory, we also have in, out, or let's do them in order, sorry. Let's do them in order so that. Buffer size, item count, in and out. So it's in the producer, you will just have a, something like integer in, integer out. And here we have the buffer size, the item count, and in and out. The same thing, you can have in and out. Now, if on the producer side, the producer does this, producer. If the producer does in, well, the producer has integer in. And then it does integer in, then it does n equals n plus 1 mod buffer size n plus 1 mod buffer size, which is what we did last time. Now this is a local variable named in the producer address space. So this is this. So when you modify, when you increment this in, you just increment this. Does the consumer know about this? No, the consumer will not know about this. How to make the consumer know about this?
Set in.
Yeah, so you need to do set in. If you don't do set in, then the consumer will not know about this. Set in, it's going to copy. What does set in do? It's going to take this value and copy it into this. So set will do this. Set in. And set out will do this. Copy it to this. And get will do the copying in the other direction. Okay? So this is a key idea. Now, okay, any question on this? So the producer will be producing items, and then it will be writing items to the buffer using the write at buffer index. So there is a function to write at a given index in the buffer. So item number 0 is written by passing the value of item 0, the randomly generated value, and index 0. So this index is going to be your loop variable, right? Because there will be a loop generating items. So this index that you pass to this is going to be your loop, your I in the loop. Okay, and this is, this calculates the address for this. So it's going to be shared memory pointer plus 4 times size of integer plus index times size of integer. So what does this do? What does this 4 times size of integer do?
Header. Skip the header.
Yeah, it skips the header. That's what it does. So you're skipping the header, and then this is whatever item number is. So it's gonna put it in this. Put it in Item number 0 is gonna go here. So these functions, all of these functions are provided for you, but you are expected to understand this. Yeah. So I may ask you about this in the, in the midterm. So you may be asked about this. So you make sure that you understand how this works, even though it's provided to you. So in this assignment, you will not be writing a lot of code. Most of the code is given, but your job is to understand the concepts. So the concepts here are parallel processing and shared memory. And these are very important concepts in this course. And this assignment is designed to teach you these concepts. Question? Okay, so on the consumer side, the consumer is going to read the values from the buffer. Then it will be in a loop consuming. So what if the consumer does this? What if the consumer, I think we're done with this. What if the consumer does this? Consumer integer in and out, and then it will do in equals get in, out equals get out. So what does get in do? This is consumer.
It's the value of the...
Yeah, it gets the value of in from the header of the shared memory buffer. This gets the value of out from the header of the shared memory buffer. Then the consumer is going to say for I equals 0, I less than item count, I plus plus. Well, item count is, you need to get item count equals get item count. And then it will say while, so now the consumer must wait when the buffer is empty. Now what's the condition for empty? What's the condition for empty from last lecture? In equals out. Yeah, if in equals then wait. Otherwise, consume item I. Now, there is a fatal mistake here. There is a fatal mistake so this will not work. So what's the fatal mistake? Yeah.
You're not updating your out value, so when you get...
Okay, so I updating the out value, so I can say out equals out plus 1 mod buffer size. Will this fix it? No, it will not fix it.
You have to get the in from the producer, otherwise.
How do I get the in from the producer?
Put it in the while loop, in equals get in.
Yeah. So it's instead of, so in will just get you the last value of in that you read from the shared memory buffer. But if you do this, get in, then you are continuously checking on the value of n that is updated by the producer. You are continuously reading the value from the shared memory buffer. Okay? So why did we do get in and we didn't do get out?
Because only the consumer should be changing the out value, right?
Yes.
Because the producer changes the in value.
Yeah, exactly. So the local value for out will always be up to date, because out is modified by the consumer. So the consumer will always have the most up-to-date value of out, but it does not have the most up-to-date value of in. It must get the most up-to-date value by calling get in. And get in means this. So this is the consumer. Get in means copy this into this. This is what get in does. Okay. So these are the key ideas.